Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we look at a useful software development skill, come up with a challenge related to that skill, and solve it live on stream. And this week we're looking at testing and isolating application infrastructure. If you'd like to follow along with the code, it is available on GitHub. You can find it here at github.com/jamesshore/livestream. Check out the tag. There it is, 2020-05-12 to get our starting point. After the stream is done, I'm going to commit the code with the tag 2020-05-12-end if you want to see where we end up. Your questions and comments as we go are absolutely welcome. Please put them in the chat. I'll take some of them as we go, and we have time at the end for further questions if needed. All right. So application infrastructure. What is it? Well, it is all the external systems that your application interacts with. It's networks and services, file systems, databases, and also any sort of global state that your application has to deal with that's not your state, although, having global state in your application is generally a bad idea anyway. But it's the stuff that is external to your application. So that includes the clock. It includes the pseudo-random generator in your code. It includes the process arguments and your error codes, your exit code from your process, and your standard out and standard error. This is all application infrastructure. And without it, our applications would just be black boxes. They'd be pure computation. We wouldn't be able to get anything in, wouldn't be able to send anything out. So we absolutely have to have application infrastructure. But it's also really often quite a pain to deal with. Tests are more difficult when you're dealing with stuff that's external to your application, and the code itself tends to be more complicated and sort of cruft up your clean, beautiful logic with all this sort of, real world junk. And who really wants that? So the question is, what is the best way to manage application infrastructure? And well, honestly, I don't really believe in best. So what are some good ways of managing infrastructure? And that brings us to this week's challenge. What we're going to be doing is we're going to be taking the Rote 13 algorithm we built last week. And if you missed last week's episode, you can find an index of all previous episodes at the link down here. Let's see, there it is, jamesshore.com/blog/lunchandlearn. It is case sensitive. So if you missed that previous episodes, that's where you can find it. But what we did last week was we built a little Rote 13 algorithm, but it was just an algorithm. So our challenge this week is to turn that into a command line application. We want to run it from the command line, pass in hello world, and see URYYB, JBEYQ come out on the command line. And to be honest, this is a trivial problem. It's really not hard. So what we're going to do is we're going to take this toy problem and we're going to do it as if it was a much bigger, much more complicated problem. And we're going to take that command line infrastructure and we're going to isolate it cleanly. So how can we do that? What is a good way of managing our infrastructure, in this case, command line infrastructure? That's our challenge for this week. I'm going to let you think about that for a moment. While you're thinking about that, what makes this show possible, what makes it possible for me to be doing this here instead of working at a real job, is all the people who hire me for training and consulting. Folks who are looking for to increase their software development game in some way, hire me to do anything from test-driven development training all the way up to helping them with their organizational scaling problems. And one of the most common things that people have is that as they get bigger, they start seeing bottlenecks between teams and difficulty coordinating and communicating between teams. And I help them solve that. So these are people of obvious good taste. If you would like to join the ranks of these above average humans, go ahead and send me an email, jshore@jamesshore.com. And I'd be happy to set up a free consultation, talk about what I can do for you and your teams. All right, back to today's challenge. What we're going to do is we are going to take our Rote 13 algorithm and convert it into a command line application, and do that in a way that manages our command line infrastructure well. So how do we do that? Well, I have two ways of doing this. First is infrastructure wrappers, and second is focused integration tests. Let's take those in turn. Infrastructure wrappers are just wrappers, an abstraction layer over anything that talks to the outside world. It's just a wrapper that wraps around any of your code that deals with infrastructure. And that's a fairly simple idea. I think the key idea here is that it's really often the code that you found, the third-party code that you found to deal with infrastructure is pretty easy to use. So it's tempting to just use it right in your application. But if you do that, you start making your application much more difficult to test and reason about. So you want to take all of that and put it in its own wrapper. And when you do that, you do a couple of things. First, you can make an API that's custom to your application. It's tempting when you're wrapping a piece of infrastructure code to just reflect the API they already have, but it's better to make the API, to really think about that API and make it custom to what your application needs, because that makes it will be easier to work with. And also, when, not if, but when that infrastructure code needs to change, and it eventually will, you're going to have to replace a third party because they're going to go out of business or stop doing what you want, or something like that. Or you'll just need to modify it, or they always tend to update versions at inconvenient times. When those changes happen, having your code isolated behind a wrapper will make it easier to respond to those changes. And keeping the API about what your code needs makes it easy to change the internals without changing the rest of your code. So that's part one, infrastructure wrappers. Part two is focused integration tests. These are unit tests of your infrastructure wrapper. So like a unit test, it's focused on just what you're making sure that your infrastructure wrapper works. But unlike a unit test, it's going to test how your code actually works with the outside world. You want to get it as close to the real thing as possible. So if you've got some infrastructure that for the file system, you're going to actually read and write real files. If you've got some infrastructure for a service, you're going to actually call a service, although maybe not the production service, depending on the situation. And so forth. So you want to get that as close to the real thing as possible, because if it's not real, if you're talking to a different kind of database or you're using a different database configuration, invariably, whatever those differences are going to be where your code fails. So you want to make it as real as possible. So it's like a unit test in that it's focused on making sure that your single class or module works, but it's like an integration test in that it's actually talking to the outside world. So it's a focused integration test. Now, one thing about these integration tests, these focused integration tests that can be frustrating is that they tend to be really complicated. You're going to probably put more effort into testing your infrastructure than you actually put into the infrastructure code, especially if you're using third-party libraries that provide nice abstractions. And I'll admit, when I'm working with infrastructure, I don't always write tests for it. I always put it behind a wrapper, but I don't always write tests for it because I'm either feeling lazy or I'm in a rush or I just don't know how. But if you can figure out how to test your infrastructure, it's really nice, because if you're not testing it with an automated test, then you have to test it manually. And that really gets tiring after a while. Or you have to have end-to-end tests in your system. This just gets old. So if you take the time to test your infrastructure wrappers with focused integration tests, the peace of mind is worth it. And I've always been happy when I've finally gotten integration tests around my infrastructure wrappers. Although, again, I have to admit, I don't always do it right from the beginning because it can be challenging. So let's look at that challenge. What we're going to be doing again today is we're going to be taking our Route 13 algorithm and we're going to be putting a hello world, making a command line application so we can do something like this hello world example or anything else that we want. So let's look at our code. And again, you can find this code online at github.com/jamesshore/livestream and check out the tag 2020-05-12 to get the code. At the end of the stream, again, I'll be checking in 2020-05-12-end so you can see everything that we've done here. Now, if you are interested in following along and you've checked out that GitHub repo, what you can do is you can run the code by running build.sh, and that will build and run the code. Everything's vendored, so that should just work for you. You will need node.js, but everything else is in the repo. If you're on Windows, just type build instead of instead of build.sh. And if you want to run the quick build, run build quick, and that will only test the things that have changed. The watch script will automatically run the test when ever a file changes, and it'll make a nice sound like that to let you know if the tests have succeeded or failed. And in addition, for this challenge, we have a run script which will run the source/run.js file, which at this point doesn't do anything. So in the code, we have run.js, which you can see doesn't have anything going on in it. And our rote 13 algorithm is in the logic folder right here. And this is what we built last time. We're not going to do anything with this, but it is available to do the actual rote 13 transformation when we're ready for it. Okay, so what we want to do is take this rote 13 algorithm and we want to make it a command line application, which means that we have to deal with command line infrastructure. So how are we going to do that? Well, first off, I like to put my infrastructure, sort of isolate my infrastructure in its own folder. So I'm going to do that. I'm going to go ahead and make an infrastructure folder to put our command line infrastructure in. And now, just as we talked about last week, whenever you're writing tests, whenever you're doing test-driven development, you want to sort of build it from the inside out. So what's the center of this command line infrastructure problem? Well, as usual, it's the interface, it's the API. What is it that we want to build? And in Node.js, the stuff that we care about, the arguments and writing to the command line, that's all handled by a global object called process. We have process.argv, which gives us our arguments, and process.standardout, which gives us the ability to write to the command line, and standard error, and we have process.exit, which will do error codes or exit codes. So it would be tempting to just make a module that wraps process and call it process. But remember, what we want to do when we're doing infrastructure wrappers is we want to think about the interface that our application needs, not just reflecting what the third party gives us. And in this case, yes, process is what we're wrapping, and it has all kinds of stuff, including the stuff we want. But the piece of infrastructure that we're making here is really just the command line. So that's what I'm going to build. I'm going to build a module or a class called command line. There we go. So I'll call it our test command line test. And let's just get this test working. We'll say that it runs tests. And we'll assert something so we can see our tests fail. And that should fail there, and now it should pass. Okay, so we've got our test working. Now, how do we want this command line thing to work? Is it going to be a class or is it going to be a module? What kind of methods or functions do we want on it? Well, I think the first thing I want to do is I want to say that it writes output to the command line. And there's a couple of different kinds of output that we're going to have in a command line application. We're going to have our standard output, and then we're going to have error output. And the error output would come if you don't put in the right command line parameters or something. I think to start out with, I want to do something like command line dot write output, and then something, my output. Now, do I want this to be a class or a module? The obvious thing to do is a class, but honestly, I don't think it's necessary. We're not doing anything that's going to have any state. So I think I'm going to make it a module for now, but I can always refactor that in the future. So I think this is my initial API. I'm going to do a command line module with the write output function on it. So let's go ahead and import our command line module. And that's going to fail because we don't have a command line. So I'll make it. And that's going to fail because we don't have a right output. And then because I'm just focused on the interface right now, I'm not going to have this do anything. Okay, so that's working. We've got the interface the way we want it. Now let's make this actually test. And what you're going to see here is what is typically common for infrastructure tests, for focused integration tests, is that actually testing this is way harder than implementing this. Implementing this is a piece of cake. We can just do console.log, or we can do process.standardout.write. That's all there is to implementing it. It's super simple. The challenge is in testing this. So how are we going to test this? We need to verify that our command line program, when it writes to the console, that we actually see that console come out. But how do we do that? We could monkey patch, we could intercept, and we can do that in JavaScript. You can do it in languages like Ruby, but you can't do it in every language. We could actually redefine process.standardout to be what we wanted. But that wouldn't test this for real, and we want to test it for real. We want to see that we're actually writing to the command line. So what that means, if we're going to do this for real, what we need to do is we need to spawn the process, write to the command line, and then see that the process actually wrote it out. And this is what I mean by saying the infrastructure tests tend to be complicated, because you have to do all this really sort of messed up setup to make it work. So this is going to get into some of the details of Node.js. This isn't a stream about Node.js specifically, and anything we do here in Node.js you can also do in other languages, but I'm going to do it in Node.js. So I'm going to set this aside for a moment. What we're going to need to do is we're going to need to spawn a process, and the way we do that in Node is with the child process module. And the specific method we want to use is called fork. And what that will do, or the function we want to use is called fork. That will launch a new, unlike the Unix fork, this is actually going to launch a new node process running the module that we care about. So it's going to be some module that we run. And that module needs to be a separate file. So we're going to need a helper of some sort, which I'm going to call command line test output runner. Now, when you're doing your focused integration test, because the tests tend to be so complicated, it's important to build them up incrementally, just like you build up normal test-driven development incrementally. But instead of seeing red, green, red, green, red, green for your incremental buildup, what we're going to do is we're going to see red and then do a little bit of manual checking and then do a little bit more, and we'll see another red and then a little bit more manual checking. And then we'll just build that up until the test is working the way we want. And then all the incremental steps in between we don't care about, so we're not going to try to keep a test around. Also, it feels silly to test our test code, so I just don't normally do that. So we want to make sure that this child process.fork is working. Now I know from previous experience that when we run child process.fork, it's effectively running it in a different thread, and this test is going to exit immediately. So I need to wait for the test for that process to be done. So I'm going to say on exit, then we'll call the done function that's provided to us by our test runner, which in this case is Mocha. So I'm going to run this and let's see what happens. So it's saying it can't find child process. That's because it should have been that. And now it's saying module not found. Project/livestream/command line test route. Okay, so we want it in the infrastructure directory, but it looks like the child process.fork is looking for it relative to where we started the program. And so we're going to have to find this module specifically. The way we can do that is with path. Say path.resolve our module's dir, and then the relative path, like that. And we'll need to import path here. And we'll need to use the absolute path here. And still failing. Module not found. Did I not create the module? Oh, I didn't create the module yet. Let's do that. Pellet, I see your question. Let me get to that in just a moment. So let's make command line test output runner. And let's just log something so we can see if this is working or not. Okay, we did get the high, but now we're getting an error on line 18. Listener argument must be of type function. Okay, and here, I thought I put in done, but I guess I didn't. I put it in the wrong spot. There we go. Okay, so now we've got our test, our process forking out. And this is exactly what you see as you do it, and you get things a little bit wrong. At least I do, because I don't use this sort of infrastructure code very often. So it takes me a little while to sort of get my head back around it. Pellet asks, do you suggest or usually wind up separating the integration tests so they can run independent of the unit tests if they start to take a long time to run? Yes, I do that. However, I do find that focused integration tests tend to run a lot faster than the other sorts of integration tests you might see in your application. A lot of people do end-to-end integration tests where they're actually running through the entire application, and those can take several seconds or even, in some cases, tens of seconds or even minutes. Focused integration tests of the sort we're doing, I find that they tend to run at about a tenth of a second each. And I typically don't have that many of them because I'm isolating them just to testing our wrappers. So those run fast enough that it's usually not a problem. Typically, if my tests start to get slow, it's because I've got a lot of code, and I'll break that code up into, I'm going to test this module and I'm going to test this module. But when I test this module, I do all the focused integration tests and unit tests for that module together. But whatever makes the test fast is what I'll do. Thanks for the question, Pellet. So now we've got the ability to run the child process, and we're seeing that it's giving us our output back. But what we need to be able to do is we need to be able to assert on that output. We don't want it to go to the command line, to our test runner here. We want it to go to our parent process. So in Node, the way we do that is we need to set an options variable, and we'll say standard IO, and we're going to say to pipe back to the parent. We can pass those options in here. Now, if I've done this right, we'll stop seeing the high show up here. And we do, so that's a good sign. And now we should be able to look at the standard out, say on data, it will call a function that will give us some data, and we should be able to log that data and see it say hi. Okay, it's not outputting a string, it's outputting a buffer, but I'll bet you that buffer, if we convert it to a string, will be our hi. There we go, good. So now we can collect that data into a string, and then when the child process exits, we can log it there. And there it is, except we timed out because I forgot the done. There we go. So again, we're building this up just piece by piece by piece by piece. This is all just getting the test to work. So now that we're logging our standard out, that's good. Now we should be able to do an assertion. We should be able to assert.equal that our standard out is equal to my output. And there we go. We expected my output, we got high. Perfect. That's great. So now we can actually run our test for real. We can say that we've got a command line, and we're going to call command line dot write output my output. Okay, and that's not writing anything at all, so the test is failing as it should. And we don't need this anymore because we put it into our output runner. Okay, so now that we've got that working, it should just be a matter of writing the code, and that is just going to be a console.log text, I think. And there we go, that's failed. I'm assuming that's because console.log puts a carriage return at the end, and we didn't. We need a new line here. I think we actually do want write output to put a new line at the end. So I'm going to say that, and there we go. So there is our first focused integration test. And again, this is hideous. Like the amount of work that we have to do to test infrastructure compared to the actual work done to write the infrastructure, this is super typical. Actually testing infrastructure can be a real pain in the butt. And I wouldn't blame you if you don't do it every time. But it is worth it to have that peace of mind, especially for more complicated infrastructure. For this, yeah, maybe it's worth it, maybe it's not. This is kind of a toy problem. Well, it is a toy problem. But so just imagine that this is more complicated and it becomes more worth it. Okay, so we're writing the output. Next thing we need to do is we need to get our arguments from the command line as well. So I'm going to take this same thing. Because it's complicated, I'll often do this. When I'm first figuring things out, I will just cut and paste, and then I'll refactor later to make it cleaner. So I'm going to put our command line argument here. I'm going to say it provides command line arguments. And we'll run our arg runner, or args runner. That's going to fail because, I would have expected that to fail because command line args runner doesn't exist. But that's not what we saw happen. I'm going to take out this assertion because it's not exactly right. That's weird. Well, let me put the command line args runner in there and let's just see what happens. I feel like it should be failing, saying that it can't find it, but maybe this absolute path logic is causing it to work in some way. So let me have this just output something. Make sure we're actually running it. And let's assert that we saw that. Okay, so yeah, it is actually running. I don't know why it wasn't giving us a failure. Well, you know what it might be? It might have been that it was giving us a failure because the module was found, or the path, I don't know. You know what? I'm not going to worry about it. So what we need to do is we need to actually test this now. So what we need to do is provide some arguments. Let's say that they're my arg1 and my arg2. And we can pass those in here. That's how childprocess.forks works. And then in our command line, what we can do is we can, again, let's grab our command line here. We can just say command line dot args. And that will give our arguments to our command line. But now we've got to get them back to our test in some way. And because this is running in a separate process, we only have our in-process communication available to us. That's standard out, standard error, pipes, and so forth. I think what I'll do is I will just write the args to the console. But that's an array, so I have to convert it to a string in some way. I'm going to stringify it and going to turn it into JSON. Now, I'm not sure and the expected output here is going to be something like my arg1 and my arg2. Now, we don't have a command line.args yet, so this is going to fail, but I'm not exactly sure how it's going to fail. Let's see what happens. Okay, we got nothing back, and that's not a useful result, because what we should be seeing is an exception being thrown saying that the method doesn't exist. And the reason we're not seeing that is because when a Node.js process throws an exception that's not caught, it writes it to standard error, and we're not doing anything with standard error. That's actually a gap in our code here. So let's go ahead and fill that gap. We'll go ahead and collect all of our standard error data, same as before. And then write it down here, just to make sure we're doing it right. There we go. There's our exception. Perfect. Now what we want to do is we want to have our test fail when we get an exception. Because right now, I think if we didn't have that assertion, yeah, the test would pass. So what I want to do is I want to say if the standard error is not equal to an empty string, then we'll log it and we'll throw a new error. Runner failed. There we go. Okay. So let's go ahead and put this assertion back in. Now we've got our test working properly. We can actually make this go. So we can make an args and I'm not going to have that do anything just yet. Okay, there we go. It's returning undefined, but that's not what we want. So now what we can do is we can just return process.argv. But that didn't work. And this is a real mistake I made the first time I used process. Actually, I make this mistake many times because I don't use process.argv every time. But when I do, I always forget that in node.js, the first parameter is the name of the program, which is normal for Unix. But then the second parameter is actually the name of the node module. So what we need to do here is we actually need to slice off the first two parameters and start with the third one. Because arrays are zero-based, that means we say slice.to. And that will give us the correct answer. And this is a real mistake that I make every time. And this is why it's useful to have your focused integration test, because your understanding of the infrastructure is often not quite right. It's going to be wrong in some way. Either the documentation's poor, or you've misinterpreted something, or you're calling a special edge case that doesn't work exactly the way you think it would. So now we just, it is working now. We just need to fix up our test to say, let's see, we want my arg1 and my arg2 like that. And that, oops, it looks like I did something wrong here. Oh, you know what? It's putting the new line on the end because of console.log. Let's do process.standardout.write. There we go. Okay, so now we've got our integration test working, but again, this is super ugly. It's very complicated. It's hard to understand. It's the complexity of the test is completely out of proportion to the complexity of the code that we're running. So what we need to do now is we need to actually refactor this, clean it up. And this, again, is something that you're going to need to do for your focused integration tests in almost every case. Getting the test to work, it's going to be all this complicated setup and infrastructure code to just get it to run. What you need to do is refactor that, pull it out of your test so that your tests tell a simple, clean story, and all the mess is encapsulated behind some helpers. In this case, what I want to do is I'm going to take this code. See, the module is unique to this test. The args are unique to this test, but this logic here is not. So I'm going to take the common logic, and I'm going to pull it out into its own method. And or function in this case, and let's call that run module. And because I like my helpers to be at the bottom, I'm going to take this and I'm going to put it down here. Okay, that should still work. I haven't done anything except a extract method. Now what we need to do is we need to get this assertion out of the helper method and back into our test. And that's a little bit tricky because this is happening inside of an event handler. But what we can do is we can either do a callback with done, or we can make this into a promise. And I like promises better than callbacks, so that's what I'm going to do. I'm going to have this return a promise by saying return new promise, resolve reject, and I'm not sure what will happen if I run that. It's still working, but we're not really using it correctly yet. what we need to do is replace the done with resolve and replace the throw with reject. Now that's going to fail because I forgot a parenthesis. I think it's going to fail because, yeah, it's just going to time out because we need to, instead of passing done through here, what we need to do instead is await run module. So I'll take the done out here and I'll say that this is an asynchronous function. And there we go. And we don't need this done anymore either. Okay. So now that we've got the ability to run the module as a promise, what we can do is we can resolve with standard out. And what that will do is it will cause the awaiting the promise to return standard out. So I can say standard out equals await run module. And then I can take my assertion and put it here. That looks like it's working, and let's just make sure that it's working. Yes, it is working. Okay, so that's factoring out the infrastructure logic. Let's clean this up. I think this can be inlined. And I think I want to leave the args as they are because I think that reads a little bit more cleanly. That's looking pretty good. Let's look at our function here. Our absolute path is, let's rename this to be relative module path. And this is all looking good. I'm going to make this a little more symmetrical though. Okay, I think that's pretty good. So now that we've gotten that working for one of our tests, we can do it for the other tests too. So we're going to need the module. This is all duplicate code except for this assertion. Oops. So we're going to say const standard out equals await run module. And we don't need to pass in the args because we're not using them in this case. They will come through as undefined. It will just work because JavaScript. So let's, I think this will work. Oh, it didn't recognize await. Let's go ahead and change this over to be await async. Okay, there we go. And let's inline this. And we can take out all of this. There we go. And now the complexity of our test is more accurately reflecting the complexity of our production code. It's still a little bit annoying because we have to look at the module in order to understand what the test is doing, but I don't know of any way around that. There may be a way around it that's super clever and complicated, but I'm not aware of anything. So I think that is it. That is our focused integration tests. That is our infrastructure wrapper. We're not entirely done yet. Let me just double check this, make sure it's the way I think it should be. Yeah, I think that's pretty good. Let's go ahead and check this in. So we've added command line infrastructure. Now it's time to actually use it. And that should be pretty straightforward. We can just go into our console, our run program here, and we can say that our input is equal to our infrastructure or our command line args, whatever the first argument is. And then we'll transform it into our output. Let me make sure I spelled that right. Yep. And then we can have our command line write that output. Now you notice I haven't put tests around this. So I've just run the test, but that doesn't do any good. We have to check this manually. And next lunch and learn, next Tuesday, we're going to be looking at how to test this using test doubles. And the time after that, we're going to look at it. In 2 weeks, we'll be looking at how to test this without using test doubles or mocks. But for today, I'm just going to write the code and check it manually. So you can see that this is a pretty clean interface. Now, again, implementing this using the actual code would not have been difficult, but imagine a non-toy example, and you can see how having your infrastructure provide exactly what you need does make things a little bit simpler for you, and it can make it a lot simpler. So let's go ahead and try this. Run hello world, and there we go. URYYB JB EYQ, and that is how you test and isolate infrastructure without having it pollute the rest of your application. I will check this code in and upload it with the tag 2020-05-12 at -end as soon as the stream is over. There's going to be time for questions. If you have any more questions, or if you want to discuss what you've seen here, I have time for questions in just a moment. Before that, and while you think about that, I have a few announcements for you. First, our next Lunch and Learn is going to be next Tuesday. It's at the same time, noon Pacific, and it's going to be about test doubles. And then the week after that, our Lunch and Learn is going to be about testing without mocks and other test doubles. So those two are both going to be really interesting sessions, so don't miss them. I also have my Casual Coding Friday live stream on this Friday at 11 Pacific, so that's an hour before this stream started. And that's going to be, if you're interested in infrastructure testing, doing more with this sort of problem, we're going to be taking this and applying it to the cribbage example we did last week. And so we're going to be doing things like, well, this is a very simple, the command line code we've done here is very simple and it's not really sufficient. We need to handle the case where there isn't any command line arguments. We need to handle the case, we need to exit with an error code when there isn't any. We need to put out, how to use the program and put out the program command line. All those sort of extra details we're going to do on the Casual Friday live stream this Friday at 11 a.m. And then again, next Lunch and Learn, Tuesday, same time, noon Pacific, and that's going to be looking at test doubles. Got some questions here. Charlie Pancakes, great to see you again. Do you have any preferred patterns for testing persistence to heavy databases? That's a great question, and that will probably be a Lunch and Learn of its own in the future. The short answer is, if you're using it may not be a short answer. Let me give you a medium answer. If you're using a ORM framework, that's going to provide your infrastructure wrappers for you. And usually ORM frameworks are really heavyweight and not conducive to wrapping with infrastructure wrappers. And if you choose to use an ORM, that is the trade-off that you're choosing to make. You're often going to end up sort of munging your ORM code and your logic all together. If you're not using an ORM framework, if you're using more of a simple SQL library type of thing, you can use infrastructure wrappers around that, and I have done that. Basically, you end up with one infrastructure wrapper for each type of query that you do against the database. Maybe one for this set of queries, and maybe another for this set of queries, and this for this kind of entities, and this for that kind of entities. So in that case, I will use the infrastructure wrappers, and I will write the focused integration test to actually write out to a test database, preferably one that I've got running on my own computer, but if not, then one that's dedicated for my testing so that I don't end up stomping on other people. Or I'll use transactions so we can use the same database. It gets complicated, which is why I would like to do it as a separate Lunch and Learn at some point in the future. I hope that answered your questions. So yeah, there's a bunch of different ways of dealing with that. One, just don't test it if you're using an ORM, or use whatever the ORM tool recommends, which is often nothing. Or roll your own using a lightweight SQL library, in which case you can use the patterns I've shown you today. Thanks. Yeah, I would love to do a stream on this. So we'll see what happens there. Pellets says, do you have any tips or techniques, and maybe this is too advanced for the time we have now, for avoiding when infrastructure has a leaky abstraction, or concepts your code shouldn't care about, perhaps forcing you to flush changes to your file or commit a database transaction? Yeah, if you have any more specific questions about that, Pellet, I can take those. Um, in general, the whole idea of the infrastructure wrapper is to hide those leaks. Is actually to wrap up those leaks. And in those cases where the leaky abstraction is relevant to your application code, then I do expose it. A good example is a program I worked on many years ago. We needed transactions. We needed business level transactions, and that corresponded to transactions in the database. So in our infrastructure code, we actually exposed something called a transaction, and it actually would, what it would do is it would collect functions. You would say new transaction, add to the transaction, here's the function I'm going to call, and collect that up and then say commit the transaction. The transaction would run through, do all the, open a database transaction, run all the functions, and then commit the database transaction. So we would expose that transaction. The leak of the extraction was the idea of committing the database transactions. We exposed it, but we exposed it in a way that was meaningful to our application logic rather than being about the database. So that's my preference, is to expose the things that you need to expose so that you don't have to worry about leaky abstractions, but do it in a way that makes sense to your application logic. And I apologize for being a little hand wavy about that. It's easier to discuss a concrete example, but I don't have one off the top of my head that I can share. I don't see any other questions, so I think this is a good point to stop. Again, what we've been looking at here is application infrastructure and what are some good ways to manage your application infrastructure? And my preference, whenever possible, is to use infrastructure wrappers, which is abstracting the infrastructure code behind a module or a class, and then used focused integration tests to test that application module. Focused integration test, of course, is just like a unit test, except that it talks to the outside world. Pellet says, I guess an example, going back to this question of leaky abstractions, an example I ran into recently was needing code to retry a network call after refreshing an auth token. But that could span across multiple calls. Yeah, so I think what I would do there is I would probably, now I'm just thinking this off the top of my head, but if I was dealing with that situation, and I think what you're talking about is a really common situation where you try something and it fails because you're not authenticated, so what you need to do is refresh the auth token. What I would want to do there is I'd want to write my network code infrastructure wrapper, and I might have a low-level network code infrastructure wrapper that a higher-level infrastructure wrapper is used. I'd want to write that code to catch those exceptions, to go out and refresh the authentication token and retry, and I'd put that all into the infrastructure layer. Exactly. Pellet says, if the response was bad token, then stop what you're doing and reauth and redo the call. Exactly. And I'd have that actually all managed at the infrastructure layer. Now, it is true that sometimes you put so much into your infrastructure layer that the infrastructure layer gets really complicated and your logic layer gets overly complicated trying to interpret what's happening. So sometimes it's good to just let those abstractions leak and expose what's really going on. And that's a judgment call that you have to make based on what you see in the code. We will be running into some of these things, but on a very simple basis on this week's Casual Friday live stream. Again, that's on Friday at 11. And in future streams, we're going to be looking at infrastructure, dealing with services specifically as a type of infrastructure. So we'll be coming back to that in the future. Uncle Scientist says, any tips on testing multi-threaded apps? Locking between threads can be tricky. It would be nice to know where locking is lacking. Nice, locking is lacking. So yeah, I have tested threading code. I never enjoy it. One of the reasons I like Node.js is because it doesn't have threading by default. Everything's single-threaded except for your I/O, and that's super clean and nice to work with. But there are times when you're doing computation where you need threading, and in other languages, of course, you have to deal with threading. So, but my general preference is to use await async types of constructs whenever possible because it makes threading's very error prone. When I'm working with threading, of course, test-driven development doesn't tell you about stuff you didn't already know about. So you have to know that there's a potential for a deadlock or a race condition in your code before you can test it. And typically what will happen, sometimes your test will start randomly failing, and that can often be because of a race condition in your threading code. So, or even in the case of Node.js and some of the callback and await async stuff. So one thing that's valuable is that when you start seeing random failures, when you see flaky tests, don't just ignore them. Don't just run your tests again. Make a note, finish what you're doing, and then come back to it. And yes, flaky tests are a pain in the butt. And I know it's tempting to just ignore them. But the more you can solve, look into your flaky tests and really fix them, the better off you'll be. So that's really the only way that test-driven development can alert you to threading problems. But if you're aware of a threading problem or the potential for a threading problem, it is possible to test threading code. And I think that would be an interesting topic for a future Lunch and Learn. But briefly, Uncle Scientist, the way it works is I will use dependency injection to control what the threads are running. And then I'll write my infrastructure to have my semaphores and so forth managed properly. And I will use dependency injection to inject into that code that is known to lock. And I'll have it just lock indefinitely until it receives a signal from my test that it should unlock. So I'll say, run this thread and lock, and then run this thread, and then I'll say, release the lock on that thing I've injected, and now I should see this thread continue on. And again, it's a little hard to describe hand waviness via hand waving, but I think that would be a really interesting topic for us to do in a future Lunch and Learn. And I would love to bring that up once we get through sort of the backlog I have planned right now. Uncle Scientist asks, is the instrumentation built into the deliverable code? No, it isn't. But what you do is you build your deliverable code so that it can have the functions that are being managed by your threading code. Those can be injected, and then you can inject whatever function you want that works however you want. And I do have good examples of this. I have done it before. I just don't have them at hand. I apologize for that. Okay, well, we're pretty much at the end of our time. I don't see any other questions on the list there, so I think this is a good spot to stop. Again, our next Lunch and Learn is next Tuesday, and it's going to be about test doubles and mocks. We're going to be doing all kinds of interesting stuff with that, and then a week after that, we're going to be looking at testing without mocks, so doing the same thing in a different way. Both of these are going to be super interesting episodes, so don't miss them. And then if you'd like to see more about how we do the infrastructure wrappers and focused integration testing this week, Friday at 11 Pacific, an hour earlier than this time, we're going to be looking at a more extended example. And again, if you like what you see here and you like it to be at your pace and covering your frameworks, your languages, your real code, then send me an email, jshore@jamesshore.com, and we can talk about how I can do some test-driven development training specifically for your teams. That's it for this time. Thanks very much, and I will see you either next Tuesday at noon Pacific or on Friday at 11 Pacific. Thanks again.